Let's begin by reading the example and highlighting important information. So when a new charter school opened in 1994, there were 290 students enrolled. Write a formula for the function n of t representing the number of students attending this charter school t years after 1994, assuming that the student population, and then we're given a bunch of different situations that can happen. So let's start by just defining our variables, writing out what they mean. So t is the number of years after 1994. So number of years since 1994. And n of t is what we're looking for, and that's the number of students attending the charter school t years after 1994. So n of t, number of students, and I'm just going to put year t, in year t. We're given one other piece of information, and that's that in 1994, which is the start, or when t equals 0, there were 290 students. So when t equals 0, we'll put n of 0 equals 290. And that's going to be true for all of these situations. So let's look at the first one. So the number of students is increased by 36 students per year. So let's just make a little chart to start to think about this. So I'm going to call this t, and this is n of t. So we know that in year 0 it started, or 1994, we started with 290 students. Okay. Now if it increased by 36 students per year, that means 290 plus 36 in year 1. Now I'm not going to compute this out yet because I want us to look for patterns. The next year it would be another 36 in addition to this, or we could think of that as 2 36s, or 2 times 36. One more year later, year 3, it would increase by another 36, so we'd have the original amount plus 3 36s. Now I'm going to add multiplying by 1 times this one. Let's get a highlighter. So notice what changes is the 1, 2, and 3. And the fixed amount, every time it's 290. And every time here we're multiplying by 36. And we could even think of this as 290 plus 36 times 0. That would be 0, and we'd get the original 290. So we've located the amounts that remain the same in the formula and the values that vary. Now notice the numbers that vary directly align with t, the time in years. Here we have 0, 1, 2, 3. So we can write that in general, in the nth year, the tth year, we're using the letter t, we would have 290 plus t times 36. Okay, so notice 290 stays the same, 36 stays the same, 0, 1, 2, 3 align with the value of t, and here's a generic t. And we like to write the number multiplied by the variable first as a coefficient. And I'm going to put 36t plus 290. And you can put these in either order. I just like to put this part first. So we have 36t plus 290. Okay. And notice this is the initial starting amount. 36, if it's increasing by positive 36 per year, you could think of that as the slope or the rate of change of this line, and you multiply that by t. Let's look at the next one. So now we have t and n of t. and we're going to start with 0 and 290 because they gave that as our starting information. But now they're saying it decreases by 24 students per year. So in the first year, we'd have 290, and I'm going to, put plus a negative 24. So we're going to add on one negative 24. They lose 24 students. The next year, they would have the original 290, but we would take off negative 24 twice. They'd lose a total of 48 students, or 2 times 24 students. So I'm going to put plus 2 times negative 24. The third year, they would have the 290, but they'd lose 3 groups of 24 students, so 3 times negative 24 students. And now let's just add like we did before. This is 1 times negative 24. We could think of this as 0 negative 24s. They haven't lost any students yet. And now let's see what's fixed and what varies. So every single time we have 290. Every single time we have the negative 24. And what's changing is this value, 0, 1, 2, 3, which directly corresponds with the year. So our generic formula for t years would be 290 plus t times negative 24. Now, like we did up here, I'm going to rearrange this. T times negative 24, we'll write that as negative 24t. And we'll write that first. It's mathematically correct either way, but we like this form better. Negative 24t plus 290. Okay, let's look at the next one. I've cleared some space for our next table, so if you need to look at the other ones, you can just rewind the video a little bit. Here it says the number of students increased by 20 students every 2 years. So let's see what this looks like. So we're going to have t and n of t. So in year 0, we have 290. Now, it's not going to be in year 1 before we had 0, 1, 2, 3. Now it's 20 students every 2 years. So I'm going to put a 2 here and add 20 students. Next, we'd have at year 4, there'd be 290 plus 2 times 20 students. Year 6, 290 plus 3 times 20 students. So notice the years are increasing by 2, and for every increase in 2 years we have another 20 students. Let's do what we did before, 1 times 20, and this would be 0 times 20. Now let's highlight what's fixed. So every single time we have 290, every single time we have 20, and what's varying here is 0, 1, 2, and 3. So notice this doesn't exactly line up with the t value. The t value is actually twice the amount of the change value. So we'll have to take that into consideration when we write our formula. So let's write it as t. We have 290. Now notice this number is half of the t value. So I can take the t value and divide by 2 and then multiply by 20. So now let's clean this up a little bit. So t equals, well, if we had t over 2 times 20, notice that's half of 20, or 10t. I'm going to write 10t first, plus 290. Okay. So now we have, in this case, the starting value was 290, and we have a slope of 10. And let's just see why this makes sense. Well, if it increased by 20 students every 2 years, and it's increasing at a constant rate, that means every 1 year, so 20 students every 2 years, if we divided these both by 2, we'd get 10 students every 1 year. So if you wanted to, we could have simplified this first to apply it to 1 year, find the slope, and then we have the initial value. So let's write this out, and we'll do that on the next problem. So here we have 10t plus 290. Now let's look at the next one. So here we have decreased by 48 students every 4 years. So let's think about what this means. So this is minus 48 students every 4 years. So if we want to see how many students we would lose per 1 year, that's like finding a unit rate, and we can divide this, and you can divide this by hand probably, but if you want, we'll use the calculator. So I'm just going to divide 48 by 4, which is 12, and notice it's decreasing students, so it's minus 12 students per 1 year equals negative 12 students per year. Now if you'd like, you can make the same chart that we did similar to this one. We would start at 290, we would subtract 12 students per year, but we're already starting to see the pattern that it's decreased by 24 students, made negative 24t. Now if we have negative 12 students per year, that would be negative 12t plus the original 290. Okay. So this is our initial value, and this is the change per unit of time. And here's the last example. Remained constant, did not change. Well, if it remained constant and did not change, we could think of this. Here's our t, here's our n of t. In year 0, we have 290. In year 1, or 1 year after 1994, we still have 290. Year 2, we have 290. Year 3, we have 290. Okay. So let's just try to make that pattern that we did before. So you can see the pattern here. No matter what t is, then we have n of t is 290. But we could think of this as the 0 change. Here it was a change of 12, 10, 24. So here we'd have 0, 0 changes. Here we'd have 1 times 0. After 2 years, it'd be 2 years of 0 change. Here we'd have 3 years of 0 change. And in the tth year, in year t, we'd have t years of 0 change. So notice, no matter what the input is, this will always be 0, and we get the formula n of t equals 290. Okay, so notice this equation does have a slope. The slope is just 0, and it cancels out, and we don't write it. So we have n of t equals 290.